closed vessel contains an ideal gas at pressure P, the root mean square velocity of the gas molecule is proportional. We can remember the equation between pressure and root mean square. P equals 1 over 3 rho C square bar. C square bar means mean squared velocity. But we have to get the root mean squared velocity. Therefore, I will use square root to both sides. Now we can get square root of C square bar. It means root mean squared velocity directly proportional to square root of pressure. And we can get half, square root means half power. Therefore, root mean squared velocity directly proportional to p to the power half. Half power means square root. Then we can get second answer is the correct answer. Which of the following graphs correctly represent the Boyle's law? They have given the relationship between PV and V. We know that according to Boyle's law, PV is constant. It is not dependent on pressure or volume. Therefore, the graph should be like this. There is a constant value for PV product. Then answer is 4. A vessel with small opening contains an ideal gas at 27 degrees at 1 atmosphere. To what temperature must this vessel be heated to drive out 1/5 of the molecules originally present in the vessel? I will use PV equals nRT. Now, pressure is a constant value and volume also constant value. Volume of container is constant. R is constant. Then we can get number of moles inversely proportional to absolute temperature. For the first situation, I will get number of moles inversely proportional to absolute temperature is 300 Kelvin. It is given as 27 degrees. 27 degrees means 300 Kelvin. For the second situation, number of moles should be 1/5 of initial value. It means n over 5. Directly proportional to, I will consider new temperature as T. Now there are two relationships. We can divide to obtain the T value. Then is cancelling. 1 divided by 1 over 5 means 5 equals to T over 300. Then we can obtain T value. 300 times 5, 1500 Kelvin. But answers are given in Celsius. Therefore, we have to subtract 273. 10 minus 3, 7. 9 minus 7, 2. 4 minus 2, 2. 1. 1227 Celsius. Then answer is 5. The molecular weight of two ideal gases A and B in a mixture M1 and M2 respectively. The ratio RMS speed of gas A divided by RMS speed of gas B is equal. We can get root mean square velocity. C square bar square root of C square bar. We know that mean squared velocity, it means C square bar, is CRT over M. Therefore, square root of this value should be equal to square root of this value. Then these physical quantities are constant, C, R and T. Therefore, square root of C square bar inversely proportional to square root of molar mass. Then we can get CA square bar root. Root means squared velocity of gas A divided by CB square bar root should be equal to MB divided by MA root. We have to get inversely proportional relationship. Therefore, we have to use MA to the denominator and MB to the numerator. They have given M1 and M2. Therefore, MA means M1, MB means M2. Square root of M2 divided by M1. Then answer is 3. A closed container of volume V contains an ideal gas at pressure P1. Then a certain amount of the gas is now removed from the container. Its pressure becomes P2. The percentage reduction of the mass of the gas in the container is. According to PV equals nRT, we know that pressure directly proportional to number of moles. And we know that number of moles is directly proportional to mass of the gas in the container. Then we can get pressure directly proportional to mass. Therefore, percentage reduction of pressure should be equal to percentage reduction of mass. Then I will write percentage reduction of pressure. P1 minus P2 is the percentage, P1 minus P2 is the pressure difference, pressure reduction. We have to divide by initial pressure and multiply by 100% to get the percentage reduction of pressure. Then percentage reduction of pressure is this one. It should be equal to percentage reduction of mass. Then we can get fifth answer is correct. J tube contains 3 cubic centimeters of dry air tapped by a mercury column. The level of mercury are same on the both limbs as shown in the figure. More mercury is now poured into the open limb until the level differ by 76 centimeters. Its atmospheric pressure is 76 centimeters. By what is new volume of tapped air? For the initial situation, pressure of tapped air column is equal to atmospheric pressure. Because of there is the same level of mercury, we know that this pressure at this point is atmospheric pressure. Therefore, pressure at this point also atmospheric pressure. Now, we have to pour mercury such that level difference is 76. Then this level will increase. For the final situation, this level difference is 76 centimeters. 76 centimeters means this difference is equal to atmospheric pressure. As a result of this one, pressure should be double because of initial situation the gas column is at atmospheric pressure. For this situation, pressure at this place is atmospheric pressure. Pressure at this level is atmospheric pressure plus H rho g. But this value also equal to the value of atmospheric pressure in mercury centimeters. Therefore, pressure is doubled. We know that PV should be constant. because of, according to Boyle's law, there is a constant temperature for the air mass. Then we can apply Boyle's law, PV constant. It means pressure inversely proportional to volume. When increase in pressure, when pressure is 2 times, volume should be half of initial value. Half of initial value means 1.5 cubic centimeter. Then we can get this one is the correct answer. The cylinder contains an ideal gas at pressure 600 kilopascal. An ideal cylinder B contains the same gas at pressure 200 kilopascal. And both cylinders are at the same temperature. The ratio density of gas in A, density of gas in B is equal to. We can obtain the relationship between pressure and density. P equals 1/3 rho C square bar. There is the same temperature, therefore C square bar is constant. 1/3 is constant. Then pressure directly proportional to density. Then we can get density of container A divided by density of container B should be equal to pressure of A divided by pressure of B. Pressure of A given as 600 kilopascal. Pressure of B 200 kilopascal. 600 divided by 200, then answer is 3. Ratio is 3. Then correct answer is 51. The fixed mass of an ideal gas at pressure P is cooled at constant volume until the pressure becomes P/2. What will be the root mean squared speed of the gas molecules if their RMS speed was originally C? We can obtain same relationship, C square bar root, C square bar directly proportional to pressure. Now they have asked root mean squared velocity. Root mean squared velocity means square root of this one. Then it is directly proportional to square root of pressure. Now we can obtain when pressure is half of initial value, C square bar also should be half, but this half is within a square root. Therefore, C square bar root should be C divided by root 2 square root. So C square divided by 2. When pressure is half, C square bar should be 1/√2 times. Now they have given RMS speed is C. Therefore, final RMS speed should be C/√2. C/√2 means third answer is the correct answer. Which one of the following when double to the greatest increase in pressure of an ideal gas is in a container? They have given 5 answers. First one is number of molecules of the gas. Second one, root mean squared speed, Kelvin temperature, volume of container, mass of gas. We know that according to PV equals nRT, we can get pressure directly proportional to number of moles and number of moles directly proportional to mass. when pressure 2 times, then number of molecules or number of moles is 2 times. It means pressure is 2 times. These are also directly proportional to number of molecules. Then, when considering second answer, we know that P equals 1 over 3 rho c square bar. When increasing root mean squared velocity, when it is 2 times, root mean squared velocity means square root of this one. When increasing square root of this one such that it is 2 times, square root of pressure is 2 times. Therefore, pressure should be 4 times of initial value. Then we can obtain maximum pressure by increasing the square bar root. It means root mean squared velocity. Second answer is the correct answer. Neon and helium behaves as ideal gases. The ratio of kinetic energy of neon and helium atoms at the same temperature. We know that according to kinetic theory of gases, kinetic energy is 3 over 2 kT. K is the Boltzmann constant. Then we can obtain kinetic energy of a molecule or kinetic energy of a gas is depending only on temperature. Now temperature is constant, therefore kinetic energy will not change. Then ratio is 1, answer is 3.